Hello, in this video I will teach you how to install a commercial fire alarm system. The first thing I need to go over is that I'm not responsible for any deaths, injuries, or damage to fire alarm equipment when you're installing this, so make sure you're careful. Always power down your fire alarm system and remove the battery connection if there is one before working on it. Most of the times when people are shocked, it's because they have the panel powered up whenever they're working on it. That's a very bad idea. Second of all, every fire control panel and every fire device comes with a installation sheet and manual, or sometimes a manual. Make sure you keep this. If you don't have one, you can find it online at the manufacturer's website. You need this; it will tell you how to install it and any other information you need. Moving along, you need an extension cord. 14 or 12 gauge is the best. If you end up using a 16 gauge, make sure you touch the end. So if it's plugged in, make sure you touch this and kind of touch this area, and then touch up here whenever it's plugged in. And if you feel it getting hot, unplug it. Usually 16 gauge is fine. The smaller the number, the thicker the wires. So if it's 12 gauge, it's thicker than 16 gauge. The wires. The kind that I recommend is this kind with the ground pin on the bottom. The purpose of ground is if a wire were to come loose in this panel and touch the box, it would electrocute you. But if the ground was there, all the electricity flows through the ground wire instead of through your body. So it can save your life or can prevent damage to fire alarm panels. If you do end up using this kind, make sure it's polarized so there's one pin larger than the other. What you're going to have to do is you're going to have to cut the end off. And if it's not labeled like mine or color-coded, what you're going to have to do is look at the smaller pin. The smaller pin is the hot pin. And since the hot pin is a smaller pin and it's the right on mine, the right wire is the hot one, so I'm going to follow it down to the end. And once I get down to the end, I'm going to label it hot or put a black mark. With DC direct current, it's called positive and negative. With AC alternating current, which is what this is, it's called hot and neutral. So the hot wire is black and the neutral wire is negative. And the neutral wire is white. So if yours is labeled, the hot one is black, the neutral one is white, and if you have a ground one, the ground one is either bare wire or it's green. So make sure to strip the wire. When you strip the wire, you're just going to get your scissors, or if you have a wire stripper, and you're going to kind of rub the blades of your scissors around the plastic part, and then you're going to kind of twist the plastic part off and pull it off of the around the wire. Make sure, since most cords are stranded, make sure not to cut any of the little individual wires here off, because it can cause heat buildup, which is not good. It can melt the wire. So yeah, so if you need help learning how to strip wire, go online. You can probably find some tutorials or videos. Also, fire alarm wire. I recommend FPL wire, standard fire alarm cable. It's usually a positive and negative wire and a little red jacket here. You can use standard building electrical wire. Just make sure the building electrical wire is either 18, 16, or 14 gauge. Usually for hobby systems, 18 gauge works fine. You'll have to look in your control panel for calculations. There's usually like an appendix in the back or like a calculating sheet in the instruction manual. If you're going to use standard building wire, THHN is good, but it usually only comes in 14 gauge. So I know some people who use stereo wire. I would not recommend that. It still probably works. Also, you're going to need electrical boxes. All wall mount notification appliances will be mounted on a square one. All pull stations on a rectangular one. And then all ceiling mount notification appliances and smoke detectors go on the octagon ones. When mounting the control panel and electrical boxes, you have to use screws, obviously. If you have drywall, the best thing for you to use is drywall anchors. There's this kind. I do not recommend this because they get loose and it's hard to take the screw out. Where did I put it? This kind I recommend, but if you can find these in plastic, that's better because the plastic ones expand in the wall. So just go online or go to your local hardware store and look for drywall anchors. They usually also work in concrete and masonry and stuff. If you have wooden ones, if you have a wooden wall, which is usually pretty rare, these should work fine. They have no ridges at the top. This is the cover of it. The metal ones are good in case you don't know where a stud is. So if you accidentally screw into a stud, that's fine. The plastic ones, if you screw into a stud, they'll just get smushed and you have to pull them back out. So I recommend the plastic ones, but only use them if you know where the studs are. The odds of hitting a stud is pretty small anyway, and if you do, you can kind of jerk it out. It can mess up some of the drywall, but yeah, if you have a stud finder, or if you can knock on the wall and hear where the stud is, use the plastic ones. If you have no idea where a stud is, use the metal ones, but the plastic ones resist more vibrations and they stay better on the wall. So when mounting these, just use 2 screws for every electrical box. You don't need to use like all 5. That's ridiculous. If you use batteries for them, what you're going to have to do is there should be included cables. You're going to line the batteries up like this side by side. You're going to connect this cable to the positive, one of the positive and one of the negative ones. And you're going to connect this cable to the negative and the positive one. And then you're going to plug this up to the control panel. Anyway, moving along. Most control panels are wired in 100. The power comes from 120 volts AC. If you have 240 volts AC, you have to look into that. Some control panels use 240 volts AC. If you do, you have to get a different type of power source and an extension cord. So, the resettable power, non-resettable power, zones, SLC, NACS use 24 volts DC. This is a conventional system, so there is no SLC loop. There is zones, which use IDCs, initiating device circuits. Here are relays, which most panels have. A relay is an automated switch, so basically, if whenever the alarm activates, the alarm relay, whenever this panel goes into fire alarm, the alarm relay activates. That's usually only used for special applications, or if you have like a communicator built in, that contacts the fire department. Most hobby systems don't have those, but anyway, when stripping a wire with a jacket over it, do the same thing when you're stripping the insulation off, but try not to cut like any of the insulation off the bare wires. So like, let me find one. This right here has a jacket on it, so you have to try peeling the jacket off. But make sure you don't cut any of the insulation on the wires inside. And then come along and cut the insulation off the wires. Whenever you do that, don't take much of the jacket off. And definitely don't take a lot of the insulation off the actual wire. You need just enough of the insulation off just to slide it under there. Don't, see like right here, this is really all you need. Peel off so it just fits under there. If you were to peel a lot of the insulation off, like on this one, see how much of that's taken off? Whenever you connect it to one of the things, one of the screw terminals, the wire would stick out, and that can cause an electrical arc, which is when electricity flies from one wire to another. An electrical arc can damage control panels and start fires. So make sure to peel just enough insulation off just to kind of get the wire underneath the terminal. So, moving along. This is a 2-wire strobe. And this is a 4-wire strobe. Well, both of these are horn strobes, actually. I only have one NAC, so I'll be using a 2-wire circuit. One positive, one negative. Since this is a 4-wire device, these are included, by the way. I use these little short wires to connect the horn and the strobe together. With this one, it's just wired to the plate. And so this is the power source from the control panel. And then this goes to the next device. And the last device on all the circuits have a resistor connected to them. This is so the control panel can know that there's no faults in the wiring. If there were to be like a wire cut or a wire to come loose, the control panel would lose connection with that resistor, and then it would say NAC fault right there. So this is a 2-wire horn strobe. This is a 4-wire one, like I said. So if I were to enable selective signs on this, since it's a 2-wire circuit, the horn on this would stop flashing, but the horn on this would stop sounding, but the strobe would continue to flash. The horn and strobe on this would still sound. If you turn off selective silence, the horn and strobe on both of these would stop sounding and flashing. So, look in the instruction manual included with the horn strobe to figure out how to wire it. So, and this is the IDC, initiating device circuit. This is a smoke detector. There's lots of wires here. There's one that's coming from the zone, the IDC here. It's not connected. And there's one that goes to the next device. And there's one for the resettable power. The IDC also has a resistor on the last device to detect faults, but the resettable power does not. System sensor does make a relay where if there's a fault in the resettable power, it makes a fault in the NAC, so it'll say NAC fault. That you can buy it separately. Most pull stations have little screw terminals on it, like this does, and like these are. But this one has just wires sticking out. The reason why it's 2 blacks and 2 reds, one is from the previous device or power source, and one is to the next device or end-of-line resistor. The end-of-line resistor, EOL, is the resistor that's put on the last device of the circuit, so the control panel can know everything is alright. Now, this right here is the cable from the previous device, the smoke detector, and using wire nuts I will attach the wires to the pull station. And these are the wires going to the next device. Since this is the last device from the circuit, I used a resistor. Now if you don't know how to use wire nuts, basically you grab the 2 wires, you twist them together with your finger, and then you put this wire nut on top of the wires and you twist it further. If I were to unscrew, no, that's the resistor one. Let me do a different one. Let me unscrew one of these. You can see here, these are the 2 red wires. See how I just kind of twisted the wires together, and then I put the wire nut on and twist that further. There's no need to use electrical tape. Just make sure they're a red wire, and make sure the wires are make sure the wire nut cap is on the wires firmly. These are yellow wire nut caps made by the company Ideal. Go on their website and look for the one that's one size below the yellow ones, and you should use that if you have 18 gauge wire, because these barely fit on there sometimes. Another thing is if by the fire code, you're not supposed to use an extension cord to power this up, and you're supposed to send your wires through conduit. You don't have to do this for a hobby system though, because this is a hobby system, it's not a real system. So basically, what happens is, like, if you were to install a device like the smoke detector, or no, this is a ceiling mount one strobe. So this would be on top of the electrical box, and there would be conduit pipe connected to this using like an adapter to hold it to the box. The wires would come through the conduit, through the hole, through the conduit, through the hole, and then it would go into the device, and then it would connect to the device. So, you know what I'm saying? It'll be connected to that. So, that's how that works. Some devices like this right here, you just connect directly to the electrical box with the holes, and then you wire it on the back. Some like this, which are the newer ones, supposed to be easier to install, which they are. Whoops! You unscrew the what's called like a vandal screw or something. It's to keep people from stealing the alarm. You unscrew that and it slides off of the base. That's not good enough. Well done. So what this is installed directly on the electrical box. The wires will come up attached to this, and then you just mount this on the base. It's a lot easier than having to kind of, install the wires in this while it's dangling down, and then trying to install the electrical box. You mount this on there, install the wires, then install this on that. So that's pretty easy. And you notice there's 3 wires. This is a 2-wire device because it's only a horn. So what you would do is you would connect the positive from the previous device here, the positive to the next device here, and then both of the negatives here. And the reason why you have 2 different ones for the positive is because if this device is moved, see those right there, it loses connection with that, and it does not allow the positive wire to go to the next device, and so the control panel will lose connection with the resistor and go into an NAC fault trouble, and so that lets you know that a device has been tampered with. So I hope you've kind of understood everything I've been talking about. Remember, everything is 24 volts DC in parallel, and the power is 120 volts AC. The wire for hobby systems should be 18 gauge, and the wire for The power source for all these systems should be 14 gauge using an extension cord. Some safety precautions is make sure to power down the panel before you work on it, like I already said, and remove the batteries. Make sure you only strip enough of the wire so it's sticking in there, not where it's sticking out or any of it sticking back out. When feeding wires through the electrical box, let me get you an example here. This one already has a hole knocked out for the conduit. You don't have to use conduit, you can just have wire coming in it. But see, when you have wire coming, don't just have like this much. Put a lot of slack in there. So pull a lot of it in. Give me a minute. Pull a lot of it in. Like if this was mounted on the wall, you should have all of this kind of tucked in there. Should have all this tucked in there, and then that sticking up to the device. The reason why is because if it's solid wire, it will snap a lot. And also, whenever you're installing a device like this, you want more slack to work with. So make sure to have lots of slack in there, not just a little bit of wire in there. There are different types of conduit, different sizes. Do research on that. And if you have any questions about electricity in general or fire alarms, go to the fire panel. Search for that website on Bing or Google, and then click on the forums button. It should be somewhere on one of the navigation bars. So for this demonstration, I removed the dress panel and the door. Those usually deattach. The dress panel covers up everything except for the controls. Another thing is, I'm not sure if I told you this yet, but here are the batteries. You're usually supposed to use 2 batteries. These cables are included. You connect the positive and negative together, closest to each other. And then you connect the positive and negative on this, and you connect this to the control panel. There's a transformer that should be included. A decent control panel would have 4 zones and 2 NACs, and a non-resettable power along with the resettable power. This one only has 1 NAC, 2 zones, and resettable power. There's no non-resettable power. So, non-resettable power is usually used with things like annunciators, I believe. If you have an addressable firearm system, the initiating devices are wired similarly, but they're all done on one big circuit instead of a different circuit for each zone. And addressable devices, there's only addressable smoke detectors. There's only 2-wire smoke detectors, not 4-wire, because they get their power from the SLC loop. So that basically covers the basics here. As you can see, everything's done in parallel. It goes from the control panel to the first device to the next device, and there's a resistor on it. Smoke detector is the most confusing because there's the non-resettable power in there. Just make sure to look in the installation instructions and keep all of them. This is all mine I have, the installation instructions. You can find them online also. But that would tell you how to wire everything. Let's see if I can get an example out. This is for a Spectre Alert horn strobe, I believe. I'm about to run out of time, so I need to hurry up, but this is this one right here. This kind of tells you, how to wire it. It says input from, power and then to next device. It shows you how everything's wired up. So these can be very helpful. Make sure to get them online or get them with your device. What else should I go over? See how this is a Firelight device? This is a Firelight panel, so they both use the same key. This is the same with other manufacturers. So yeah, that's it. I'm about to run out of time. If you have any questions, go to the Fire Panel forums or message me through YouTube and I'll help you out. So click on the pull station to go back to the main menu. If you click on it, you can learn about compatible devices and how firearm systems work. So go ahead and click on the pull station. Alright, bye.